It seemed earlier on that there was 5 or 6 other people there that seemed to know quite a lot about the cloud as well, so I'm not sure that's quite justified. What I wanted to do this afternoon in the sort of next 20 minutes or so is just to take a quick look at the recent cloud computing phenomenon which has kind of swept through the IT industry in the last few years. And that same kind of phenomenon is starting to make inroads, as we saw earlier on, into our own industry. I want to look initially at the fundamentals and history of cloud computing. I'm just realising that I have nothing to advance my slides with, so is that something that can be provided? Yeah, can I control that? Thanks. I'm a control freak. But yeah, we'll look initially at the fundamentals and the history of cloud computing. Oh, this is going to be one of those afternoons, isn't it? Oh, there we go. So yeah, we want to look at the fundamentals. We'll consider the cloud technologies and what their role is in the broadcast industry. And as part of that sort of consideration, we'll examine the key technologies such as server virtualization and data center automation, on which those kind of things depend. And finally, we'll conclude with there we go, works if I hold it up. Finally, we'll conclude with a look at the benefits that these technologies can bring to an organization. And there might be some time to answer some questions if I haven't hopelessly overrun by the end of it. So let's just start by looking at some of the fundamental technologies that have made this all possible, and some of the historical context in which they've occurred. It's actually a useful exercise because what we'll discover is many of these technologies, although they can kind of seem a bit sort of new and scary, they're actually often built on technologies that have been around since the early 60s and 70s and the very birth of computing technology. The sort of first documented use of the term cloud was probably in a paper from MIT around 1996. But cloud computing is a term that we have to look much more recently to. Eric Schmidt, the CEO of Google, is probably widely acknowledged as being the first person to use that phrase in 2006. And it came just a few months before Amazon launched the Amazon Elastic Computing Cloud, or the EC2 as it's often referred to, which is one of the first commercially available public cloud platforms. The technology which has actually made the cloud possible is actually based on a set of technologies, as I said before, which can be dated right back to the early mainframe computers of the 1970s. So one of those key technologies which I want to just briefly look at is server virtualization. Server virtualization is the underlying technology that makes true cloud computing possible. So what exactly is it? If we take a typical IT server, we've got the main components, a CPU, we've got some input-output, a network card, we've got some RAM memory, and we've got some permanent or persistent storage in the form of a hard disk drive. And those 4 components basically make up the this is hopeless. There we go. The physical host. And installed on that is usually the operating system that we plan to use with the system. And on top of that, if this was a non-virtualized system, we put our various different applications and install those on top of the system. However, in a virtualized system, we can install a piece of software which is often referred to as a VMM, or a virtual machine manager. And this sits on top of the OS, or sometimes it can replace the OS. And it uses time slicing and memory allocation and various other tricks to basically fake to applications that are using it a number of virtual machines. And these virtual machines are important for a number of reasons. First of all, they are completely self-contained machines, and they can run applications in a totally isolated environment. This isn't an emulation technology It's a complete virtualization of a physical machine. As I said before, in certain circumstances, the actual virtual machine manager can actually get installed directly onto the machine itself and replace the operating system, what we tend to refer to as a bare metal install. It's also possible for the virtual machine manager to work across multiple hosts at the same time. So if you imagine in a data center situation where we've got, say, 3 physical hosts, we can actually run the software across the entire physical platform, and that actually allows us to do some quite exciting things. Promised you this presentation would be exciting. So first of all, we could have a situation where we've got a couple of virtual machines running a couple of our critical applications, and a few more there. So we've got 4 virtual machines running, we've got 5 applications that are in use there. Let's suppose one of our physical hosts actually dies. At that point, we lose 2 of our virtual machines. And if this was a traditional server situation, we'd be in a bit of hot bother at this point. As broadcasters, we'd be off air, and we'd have problems and complaints. In a virtual situation, because the machine itself isn't physical, we actually know what the current state of the CPU is. We know what all of the different ins and outs are doing at any given time. So what we can actually do in that situation is we can actually physically move the machine, virtually move the machine across to a host that hasn't been affected. And we can restart those applications in that situation, which allows us to basically mitigate those kind of risks of hardware failure and so on. It may actually sound a bit sort of far-fetched, but it's actually a technology that's been in use in IT data centers across the globe now for almost half a decade. It's this technology that's been underpinning the cloud revolution that's sort of sweeping through the IT world at the moment. But the roots of the technology can actually be traced right back even further than that. As early as 1959, Chris Strachan wrote a paper about basically the building blocks of what we now call a virtual machine manager. And in 1964, those ideas were taken by IBM and basically turned into the System 360 and System 370 mainframe computers. I won't embarrass anyone by asking if they remember those machines. I certainly don't. But they used virtualization to make sure that they were kept utilized. By 1981, IBM had launched the IBM PC based on the Intel x86 chipset. And by the time we reached 1990, those PCs had become so cheap that they'd almost become commodity items. With the advent of Windows NT and Linux, we had a robust server platform that we could run applications on, which previously we would have had to buy a Sun or a DEC Alpha machine, or even a mainframe. By the time we get to 2000, virtualization for those x86 mainstreams had become a mainstream thing that could be done. We'll go into a little bit more detail about why that happened in 2000 in a little bit of time. And today in 2006, we find ourselves, today in 2011, we find ourselves in a situation where there's a plethora of these cloud services, and it's really that I want to get to today, just explain to you a little bit about how the market works and what sort of services are available, and then how they can actually apply to us in broadcasting.
Okay.
So how is it that server virtualization is able to help mitigate the effects of something that we found in the year 2000, which was a phenomenon called server sprawl? What was happening is manufacturers, IT managers were finding that they had incompatibilities between different applications. So you'll have all come across the problem where you've got one application that needs Service Pack 2 and another application that requires this DLL. And so the easiest way to solve that is you install it on 2 separate machines. And that was happening on a massive scale in IT data centers across the world. And it was becoming a major problem. If we go back to 1970 with the IBM System 360, we were in a situation with that system where it had relatively low CPU speed, but it had quite high utilization because this was an expensive piece of kit. You're talking £250,000, £300,000 in today's money to buy those sorts of machines. So the virtualization was used to keep those machines running all of the time and keep them busy. If we flick forward to 1990, with the x86, the Intel-based machines, suddenly we find the CPU speed is astronomical compared to those early mainframes. But the utilization of those machines is very low. Basically, they sit there and spend most of their time doing absolutely nothing, and yet they're still consuming power. But nobody cares because the cost is nice and low. So we've got almost the opposite situation that we had back in 1970. So why virtualize? What was the catalyst that caused it to happen? The cost of electricity and cooling and even the space required for data centers was becoming a major issue for IT managers and CEOs. Moore's law kept producing machines which got ever faster and faster, so every 18 months the number of transistors available was increasing. But actually what IT managers were looking for was a way to actually reduce the physical number of servers that they had, because they were having compliance issues and they were having issues with being able to actually support that number of machines and the physical space that it was taking up in their archives. It basically all came to a head around about the time of the dot-com crash in 2000. It's often referred to as the dot-com crash, but actually it was, if you look at this snapshot from the NASDAQ, it was actually something that covered all of the technology stocks. And actually server sprawl was one of the major contributors to that event. It caused IT companies to basically spend unprecedented amounts and really unsustainable amounts on their yearly IT budgets. And as that bubble started to burst, companies like Amazon had to look for ways in which they could reduce that server sprawl and increase the utilization of their data centers to basically to survive. What they discovered was that the same virtualization techniques that IBM had used in the 1960s could actually be used on their x86 servers to the same effect. And server virtualization, the foundation of cloud computing, was born around about that time. So virtualization, as we saw before, became the solution to this server sprawl problem. Virtual machines allowed for complete isolation between applications. It meant that previously incompatible applications and even whole operating systems like Linux and Windows could run on the same physical PC at the same time. At the same time, data center automation techniques were being developed which allow these virtual machines to basically be started, stopped, managed, looked after, terminated, moved, all while they're still running. Combining those two key technologies became the foundation of the modern cloud computing that we see today. Just to kind of reinforce the roots that it has in the early computer scientists, this is actually a quote from John McCarthy, who wrote it in 1961. And he said this: "If computers of the sort I have advocated become the computers of the future," and they did, "then computing may someday be organized as a public utility, just as the telephone system is a public utility. The computer utility could become the basis of a new and important industry." It took the biggest technology crash the world has ever seen to jumpstart that process that McCarthy predicted, but we're well in the middle of that revolution, a movement away from CapEx to an OpEx operating model, a movement away from physically buying machines and owning our own staff to outsourcing to companies that can provide that sort of service for a much cheaper price. So now we know what cloud computing is and where it's come from. Is it something that we can actually use in a broadcast context? To answer that question, I think it's worthwhile considering some of the typical applications that we see in the kind of broadcasters we've got represented in front of us today. Let's first of all look at some of the back office functions of a broadcaster. If we take a look at things like scheduling, rights management, and ad sales, to a large extent those kind of applications look very similar to IT applications that we see every business running. So applications like Microsoft Exchange Server, SQL databases, things like that. Those kind of systems are actually incredibly well suited to being run in a cloud-based model, and in fact there are already systems on the market today, rights management systems that you can run in that kind of